So, first question, who are you, what's your role, and who do you work for?
Hi, I'm Deepak. I head the cloud native engineering at Nutanix. I mainly focus on Kubernetes, that is our Nutanix Kubernetes platform, and Nutanix Data Services, that is NDK at Nutanix.
What are three emerging Kubernetes tools that you're keeping an eye on?
So I would say the first one would be Kyverno. I really like that tool which make policy as a code. One of the big requirements in Kubernetes how to put the guardrails, and Kyverno being Kubernetes native makes it really easy to express those policies in terms of YAML files and objects. So that's pretty promising. The second one I would say is Flux. We know how difficult is Kubernetes configuration management, and one of the ways to handle that is through GitOps, and Flux really makes it easy to integrate with the rest of the platform. So that's fairly promising. And the third one I would say is Metal 3. So our Nutanix Kubernetes platform is cluster API based, and Metal 3 extends the infrastructure on bare metal, which is where I think industry is heading now as we are transitioning from the last decade virtualization to containerization. It's becoming important to have a solution like Metal 3 where you can run Kubernetes on bare metal. So that's pretty exciting.
These are questions based on comments that our guests in the podcast have said. So, the first one, automation and resource management. Alexandra expressed that having an automated mechanism is better than enforcing processes. What automation tools or approaches do you recommend for managing Kubernetes resources?
So one of the big challenges that I have seen over time in Kubernetes is sizing. So when you deploy your application, the very first questions that comes to mind is what resource you should allocate to this application, how much CPU, how much memory, and really there is no easy way to figure that out, because even though these entities are static, they are very dynamic in nature, right? So as your application start handling more load, it might need more CPU and memory. So I would recommend in that case to use Kubernetes features like HPA and VPA, and I'll briefly talk about what are those. So HPA is horizontal pod autoscaler. So it scales your pod, your application, by creating more pods if your application needs more load to handle. Whereas VPA is a vertical pod autoscaler. It changes or modify your resources based on the demand of your application. So what happens is it automates the resource management in your Kubernetes clusters and take away the burden from statically defining these resources.
GitOps and platform engineering. One of our guests, Hans, argues that GitOps is an excellent building block for building platforms with great developer experience. He mentioned the ability to merge, review, and discuss code changes in PRs and the additional benefit of not granting permissions. Should all platforms use GitOps? What's your experience?
Absolutely. One of the bigger challenges or one of the missing areas in Kubernetes is configuration management. So even though you have audit logs, but those are more reactive in nature than proactive. So when you make a change, especially in your production cluster, you need to make sure that the changes are not leading to a downtime, because seemingly unimportant change might bring your application down, which is where GitOps or especially Git system comes into handy, because you can have reviews, you could deploy it in a very automated manner, you could have a history of changes, which is called version control system for your configuration. So it brings about both the security, the guardrails, and the automation that will help run the Kubernetes cluster in a production environment.
Regarding multi-tenancy, our guest Artem shared that once you slice your Kubernetes clusters into a multi-tenant environment, you should consider multi-tenancy for every tool you install, such as logging, monitoring, scaling, etc. What's your advice on building Kubernetes platforms that are shared in an organization?
Yeah, I mean, I want to take a step back on multi-tenancy before we go, because there are two types of multi-tenancy which we know traditionally, which is hard multi-tenancy and a soft multi-tenancy. So hard multi-tenancy is where you deploy different Kubernetes cluster for different groups, because they, for some reason, they need a dedicated Kubernetes cluster and they cannot share. But if you have a team or multiple teams that can share a Kubernetes cluster, then soft multi-tenancy is in play. Now, I do agree that soft multi-tenancy in certain cases, like especially observability stack, logging stack, and others, needs to be deployed in such a manner that they are multi-tenant in nature. So now either you have applications that can handle the multi-tenancy at the application level, or you have namespaces, which is the multi-tenant construct in Kubernetes. You have multiple copies of your application deployed in each namespace, such that you take benefit of namespace multi-tenancy. But before you go deeper into the multi-tenancy, you need to ask yourself a question whether you are opting for a hard multi-tenancy, whether your team needs a dedicated Kubernetes cluster, or can they use an underlying same Kubernetes clusters to deploy application in a soft multi-tenant manner.
Kubernetes turned 10 years old this year. What should we expect in the next 10 years to come?
So the first 10 years were marked sort of educating the industry that container is the de facto way of deploying modern application. I think there's a general acceptance now after a decade of that exercise. The next decade, I would say, would be led by more automation, because one thing we have been seeing year after year in CNCF survey is that Kubernetes is still hard to operate, right? There is a skill gap. And to me, it feels like we haven't yet reached to the level of right abstraction or interfaces and automation to make it easy to be adopted, right? So the next decade, I would say, we would be able to build right interfaces, right automations in Kubernetes, such that Kubernetes becomes an internal implementation detail and not so much exposed as it is exposed today.
What's next for you?
I am big on building something which I compare with self-driving car, right? So as the car industries have moved from exposing the entire engine to now just inputting your destination, I want Kubernetes to follow that same path. So we have exposed Kubernetes construct, which made it difficult for everybody to understand what they are. I think we need to build the abstractions such as right steering, right brakes, right accelerator, so that the driver of Kubernetes need not understand the internals of Kubernetes, but still able to use it for their own benefit. And then we reach to the automation level such that it is self-driving, self-operating, self-healing. That's where I focus more on, is to how to make Kubernetes easy to consume. Basically abstract it away so that we stop talking about Kubernetes.
How can people get in touch with you?
Easy. I mean, I'm on LinkedIn. Anybody can reach out to me on LinkedIn. Deepak Goyal, C2D2IQ. That's the easiest way to search me. Yeah, I'm most active there.